Hi everyone, this is lesson 2.4, Picturing Data with Graphs. So let's go ahead and read specific objectives. Students will understand that the scale on graphs can change the perception of the information they represent. To fully understand a pie chart, the reference value must be known. Students will be able to calculate the relative change from a line graph, estimate the absolute size of the portion of the pie chart given its reference value, and use data displays onto graphs to estimate a third quantity. Now, looking at these objectives, you already probably realize that we are going to be going over similar terms like relative change. We already discussed that. Talking something about absolute, the reference values. So all of these terms you have seen before. But what's new is that today we're going to be focusing on diagrams, and we're going to be interpreting these ideas through those graphs. So first we're going to take a look at the line graphs. So let's look at the problem situation number one. Suppose you're part of a political team that wishes to argue in favor of economic policies of New York State Governor Elliot Spitzer, who was a governor for a short period of time, and David Patterson also was a governor of New York State for a short period of time. I want to look at the policies on unemployment and see how things how the data changed. So here are the graphs that were created using the same data. Important to note that it's the same data and the same Excel program. Alrighty, so here you see the two graphs. Okay. So what do you notice about them? What does it depict? What does it show? All right, so question number one, based on these two graphs, would it be fair to say that the unemployment increased dramatically from 2007 to 2010? So look at the both graphs and write a sentence or two describing did it increase dramatically, and if it did, then describe why. You don't need to bring any numerical information for now, just looking at the graphs. What do you see? All right, so let's review. Now, looking at this, understand that if we look at the scale, we are given the time period on the horizontal axis, and we are given the percent of unemployment of what percent of people in New York State were unemployed in a given particular month. All right. And if you look at the two graphs, you notice that the first graph looks like it's rising, correct? While the other graph looks like it's flat, correct? So how can it be explained that you're using the same data, but one showing an increase and the other one is showing that it's remaining flat? And you probably noticed that the difference is the scale. Here the scale goes up by 1, while here the scale goes by 10. All right, so that's why they depict similar information by it's the same information, but the graph displayed absolutely different is because of the scale. All right, so which one shows us that unemployment information better? Graph number one or graph number two? Select your answer. Yes, graph number one depicts information much better because we can clearly see what's going on. Now let's see if it will be asked to calculate anything. No. So we actually, can take a moment and use graph number one. And what I would like you to do is I would like for you to calculate the absolute change and the relative change in the unemployment percentages going from the beginning where we have the data and the end. Okay, so let's begin with the absolute change first. All right, let me give you a moment to calculate that. All right, so we need to read the graph carefully. So what it is in January 2007. So in January 2007, the number that we see is somewhere right here, right? So if we zoom in here a little bit, you see it's more than 4 but less than 4.5. So maybe like 4.2. Again, we don't have to be exactly precise, but to get an idea of what the change is. So 4.2%, and then it goes to January 2010, which is, if you look at the graph right here, this is really, really close to 9, correct? Very close to 9, maybe slightly less. I would say maybe like 8.9%. So that if we go ahead and calculate the absolute change, we just subtract the two numbers. All right, so 8.9 minus 4.2, which gives us 4.7%. Now notice, it is absolute change, so it's just a difference, but the units that we're using are percent. So it doesn't mean that the fact that we're using percent, it's all of a sudden a relative change, because we didn't do the calculation for the relative change. We didn't divide it by the original amount. So even though we're using percent as figures, as numbers, they can also change. So we can describe an absolute change in percentage units, and we can also calculate the relative change in percentage units. So what I mean is, this is actually the absolute change, which is the change in the percent. Now, the relative change has the same kind of formula, the same way you calculate the relative change. You say now minus the past divided by the past, and then you multiply it by 100 to convert that into a percent. Correct? So take a moment and take these two numbers and calculate the relative change in those two, and then we'll review. All right, so let's do it. So we got 8.9. Well, actually now minus the past. Yes, so 8.9 minus 4.2. We can even write it as a percent. You see, instead of using percent symbol, I use like PT, just not to get confused with the fact that I am still finding the relative change. So that means we're going to divide it by the past amount, which is 4.2. So I'm going to grab my calculator and get the result, multiplying it by 100 as well. So 8.9 minus 4.2 we already did. It's 4.7 percentage points divided by 4.2. Notice that the numerator is bigger than the denominator. So when we actually do the calculation, we expect the change to be more than 100%. So let's check this out. So we get times 100. So we get 111.9%. All right, so if something increases by more than 100%, that means it's more than doubled. 100% increase means that you had 100 original plus another 100, so it became 200%, which is commonly stated as a word twice. All right, so and you can see that 8.9 is more than twice as large as 4.2. Okay, so 100% increase corresponds to doubling. Okay, that's also kind of an important concept. All right, so if you look at this, is this a dramatic increase? Absolutely. So during this period of time, in 2008, there was a great recession, and unemployment has gone up pretty high across the country, including New York State. The pandemic of 2020, of course, also has its own statistics, but so far it was not integrated in our lessons. So at some point it probably will. Alrighty, so let's go on to question number 2. Which graph would you choose to make a case to defend these government policies and why? Alright, so what is the government policy? So the government policy says that, Spitzer was in 2007, 2008, so he was up to here. and Patterson was for the rest of the term, for the rest of the graph, right? So we can put S here for Spitzer and the other one, Patterson, right here. So it says you want to argue in favor of the economic policies. So if you want to show that, things were not too bad in New York State, then which graph would you choose to show that things are okay, things are not looking as drastically bad? Let me give you a chance to select the graph. Yeah, so the answer is graph number 2, because graph number 2 shows like it's flat, like nothing changed. And of course, that's not the case. If we just did the calculation, you can see that for both period of time, the unemployment did go up, but it was more dramatic on the Patterson because of the sharper increase in the graph. You can see the numbers rise from like about 5% to about 9%, while for Spitzer it started at 4 and it ended at 5, so it's much lower increase. But again, the recession of 2008 would explain that higher increase for the period from 2010 to 2008. Okay, so here we're going to put graph number 2 because it shows like that things are more or less flat. Now we're going to look at the other graph, also talking about unemployment, and it is comparing New York State from New York City. So New York State is the solid line. All right, so this one is the solid line. And New York City is the dotted line. Was unemployment worse in New York City or in the state overall over the same period of time? So if we look at the numbers here, the New York State we already calculated, right? So New York State, we got the absolute change was, what was the absolute change we calculated earlier? So it's 4.7%, and so it's 4.7 percentage point, and the relative change was 111.9%. That was for the whole state. If we look for the city, so the city is going to be the dashed line. So the city went from like maybe 4.5, a little higher than New York State. For New York State, I think we used 4.2, right? So for New York City, it was a little higher to begin with, so maybe 4.5. And it ended up right on the line right here at 10%. So that's for New York City. So go ahead and calculate both the absolute change and the relative change in those two numbers. I'll give you a moment. Okay, so the absolute change, just subtract again, it's a review of what we already did. The absolute change is going to be 5.5%, while the relative change is going to be that difference divided by the original. So if we calculate that, we divide 5.5 over 4.5 and multiply it by 100, it gives us 122.2%. So as you can see, both the absolute change and the relative change in New York City was higher. All right, so the city unemployment rate during that time was a little bit more affected, was a little bit higher than state as a whole. But also remember, New York City compromises half of the state, right? There are about 8 million people in the city and about 18 million people in the state. So, a lot of unemployment in a city contributed to the unemployment of the whole state. So you probably would need maybe a better data in order to compare the two. I would probably look at New York City as one place to look at, and then everything that's not New York City, but part of New York State, and see how city compared to the outside of the city. I think that would be better comparison than this. Anyway, the point of this question was to review the absolute and the relative change, and read it from the graph, and also understand that the scale can be deceiving. So the more refined the scale, the easier it is to interpret the graphs, and it's easier to see the change. All right, here's we're looking at the other graph. So we look at the line graphs. Now let's look at the bar graph. So here's the bar graph, and it tells us the cost of the subway ride, and from the years from 1948 to 2013. So it was few cents. Maybe it looks like it's 20 cents. It's not clear here in 1948, but it has been rising steadily. So I'm going to add just one more data for current time, since it's not in the chart. So for 2021, we know the subway ride is $2.75. So we're going to make this chart right here. So it's close to $3. So that would be 2021. All right. So that's the nominal subway fare. Nominal means how much you paid in a given moment in history. So here we go. So here you have one graph. Now looking at the other graph, it's adjusted to 2020 dollars. We're going to have a lesson on inflation a little later in the course, so we can discuss this idea. But basically, the overreaching concept is that the money in the past, let's say in the year 1990, for instance, okay, the $2 in 1990 could buy more goods than $2 in today's money. All right. So even though things look cheaper, all right, in a given period of time, like let's say a cost of the subway was only in the year 1990 was only $1.25, but that $1.25 in 2012 dollars is actually $2, right, in that year. So when we're adjusting something to inflation, we just see what's the cost was in the current money in a way that we can compare. All right. So we're going to discuss this deeper, but this is what this graph is showing. All right. And by the way, if we adjust the cost of the subway fare right now to the 2012 dollars, so $2.75 in 2021 translate to a smaller number in 2012. So I did the calculations, and we're going to do those calculations later on in the course. So it's actually $2.33. So if you graph it, it's going to be somewhere here. So that's the data for 2021. Just kind of interesting, right? So it doesn't mean that the cost of the subway right now is $2.33. No, I'm just saying that the amount of stuff that we can buy for $2.75 today, in 2012 we only needed $2.33 to buy exactly the same thing. That's the idea of inflation, is that the money, as time goes by, loses its value. All right? So things are becoming more and more expensive. But if, for example, the subway ride stays the same, then in a way it becomes cheaper because the inflation goes up. All right, relative to everything else, $2.75 is now $2.33 in the 2012 dollars. It's a very interesting and important concept, so we'll explore it even more. But let's continue looking at these bar graphs. This is nominal subway fare as a percent of the minimum wage. So the minimum wage is a federal number, and each state also has its minimum wage. It's usually hourly wage. So we know that in New York City, the minimum wage is $15 per hour, but in the entire country, it's still $7.25. It has not been changed, but it looks like it will very soon. So for now, it's still $7.25. So I just want to show you how you do the calculations that was done in that chart. So for year 2021, the subway ride cost $2.75. It takes a federal minimum wage is $7.25. So then, what is? Oh, I put the percent symbol. What is the subway ride as a percent of the minimum wage? Can you find that? Let me ask you a moment and go ahead and compute it. So what is 275 as a percent of the minimum wage? All right, so let's review. So if you take $2.75 and you divide it by 725, and multiply by 100, then you will see what percent is that. So I'm going to put that in the calculator right now. So it's about 37.9%. I'll put it as 38%. So if you put that on a graph, 38% will go right here. So it has risen slightly from the year 2013. So this is 2021. So that gives you an idea of how things are relative to something else. That's what you want to get. So yes, prices have been going up. Yes, for everything. All right, now, but when it comes to adjusting them, then here's what you see. See what you see for the subway ride. So now here's the question that's being asked. Consider a statement. Riding the subway in New York City keeps getting more expensive with each passing year. Is this statement an accurate statement? Explain in a sentence. So let me go ahead and give you a chance to write your answer. All right, let's review. So this is false. From the graph that we see. All right, yes, it's increasing. I'm not claiming that it's not. It is going up. But when you look at how does it compare to relative cost of everything else, it has remained steady from the year, I would say maybe 1972. It was like ranging around $2 to $50, so it hasn't been gone that much higher. All right, so relatively to everything else, it was okay. And then looking at the percent from the minimum wage, it's also kind of staying below 40%. So I would argue that it's false. But of course, if you want to say that, yeah, it's getting out of hand, then you would be claiming, look, it was only $1 in whatever year, and now it's almost $3. True, but relative to everything else, it has been increasing gradually, and not as much if you compare it to everything else. So that's the concept. I mean, that's the math. All right, so that's what we argue when we try to making changes in policy. All right, so now consider the statement from 1970 to 2003, New York City subway was getting extended for the city lowest earners. Which of the graph best supports that claim and why? So if you're looking at the minimum wage graph, so we're looking from 1970 to what year, 2003, hasn't been increasing. If you look at the trend, kind of yes, right? So if you look at the adjusted to $2012, it's kind of remaining steady, but as a percent of the minimum wage, that subway ride has gone up. And here you can argue that people who were earning minimum wage, they spending 38% of their hourly wage of working 1 hour in order to use the train each way. So it's like, if you think about this, going to work and back, that will almost be 80%. So it's going to be like your hour that you work is the cost for you to commute. So not only it takes you, for some 2 hours to commute, it also you work an hour just to pay for that. You know what I mean? So in this case, yes, you can argue that graph number 3, that third graph, does show us that the train, subway ride became more expensive for the lower, or people of the lower income who work minimum wage. All right, so problem situation number 3, reading the pie chart. So it's looking about the percentage of U.S. population by age, and then you're projecting it in 2060, and this is what the chart would look like. All right, this is a pie chart. The whole thing equals to 100%. It says that the pie chart above show the changing age demographic in the U.S. Summarize the trend reflected in this chart in a single sentence. So let me give you a moment. All right, so here's the picture. Okay, so let's review. Well, looking at the chart, it looks like that the older population, the over 65, is going to rise. It's a bigger piece of a pie, as you can see. The younger population under 18 look like as a percentage is going to fall, as well as the group between 18 and 65 is going to fall. So in one sentence, I would write population over 65 is projected to increase as a percent of the entire U.S. population. Percentage is projected to increase. So that would, that what you could write. For part 2, suppose that you have been hired as a consultant for a large corporation that specializes in toys and video games. The CEO has seen the above data and is concerned for the future of his company's business. He proposes that the company begin plans to phase out several factories because there will be fewer kids to buy their products in the future. Would you support his business decision? Explain why or why not. So they want to downside the business because basically because of this. Right? It looks like the younger population is going down. Do you agree with that statement? Write a sentence saying yes or no. All right, so you might have written that, sure, it's the right decision because the percentage is going to decline, and that's a valid reason. Sure, I'll accept that. So there's no wrong answer yet because we haven't done any calculations. And the last question of this lesson is asking you exactly that. It says that it's included in a census that we have numbers of how many people are there in the United States and what is it projected to be. So 2014, it was 319 million. And 2060, it's 417 million. Use these figures to calculate the absolute and the relative change in Americans under 18 years of age. So let me write those numbers right underneath each chart, and I'll ask you to take a moment and calculate what it's asking us to calculate. So let me write down the numbers. So we got 319 million right here. And do not write it in expanded form. Just leave it like that, as millions. And then 417 millions for 2060 projected. We're going to be focusing only on the 18 category. So first question that I want to ask you is to calculate in 2014, how many people were living in the United States that were under 18 years of age. Okay, so calculate that number. Go ahead. All right, so let's review. So it's 23% of 319 million. All right, it's going back to the same type of calculations we've been doing. All right, so let's multiply. All right, so we take 319 and we multiply by 0.23. I'm using my calculator. leave it as millions. So it's 73.37 million kids. Now let's do the same thing for 2060. Under 18. Let's calculate that number. Let me give you a moment. Let's review. So it's 20% of 417. We do the same thing. 0.2 multiplied by 417. That gives us 83.4 million. Very important observation. Let me highlight those two answers. This number and that number have increased. All right, so take a note. Even though the percent went down, the amount actually of kids went up. And the reason for that is why? Because the population is projected to increase. So a smaller percent of a larger number ended up being larger than a larger percent of a smaller number. So here it goes. Now the question is asking us to compute the relative and an absolute change. So go ahead and find the absolute change first and select your answer in the highlighted blue numbers. All right, so let's review the absolute change. You just subtract them. Just subtract them. I'm not writing it. You're just minusing them. So that's about 10 million people, kids. That's an increase. All right, it goes up. And the relative change, the percent change, is the difference. So 83.4 minus 73.37 and divided by the past amount. Keep that in mind, okay? Whenever you calculate the relative change, you always use the past figure to compare. So 10.03 divided by 73.37, and that gives us 13.7%. So going back to that question, should the CEO downside their business? I would say no. I mean, even though percent is going to decrease, the number of kids will still going to climb. So it probably makes sense to even expand it. And on that, we're going to finish the lesson.